Hi friends, in this video we are solving problem from the triple integral. This topic was chosen from multiple integrals. So here we have to do evaluate integral 0 to pi by 2, integral 0 to a cos theta, integral 0 to a square minus r square or dz dr d theta. Here you observe it is a function of r. So I am writing just simply f of r. It is a function of theta. Next, okay, remaining last you have it is 0 to pi by 2. Friends, you know that 0 to pi by 2 is nothing but angle only, na? So angle is obviously limits for what? Theta. So theta is over. Remaining r and theta is only left. R and z is left here. So theta is not a limit for theta. So obviously it will be limit for what? R. Next, r is a function. R is not r already over. Theta is also already over. So obviously it is a limit for what? Z. So like this you have to identify the limits. You see it is having angle, limits are angle, so obviously it is a limit for what? Theta, and rest of terms you have it is a function of theta and function of r. Function of theta is not a limit for r, not a limit for z or theta. So obviously this is limit for what here? In this case r. Now it is a limit for what you have? Remaining term what you have? Z. So this is limit for z in this case. Now integrate we have to do. First you observe it is having dz, so first you have to integrate with respect to z, and later we have to integrate with respect to r, and then we have to integrate with respect to theta. So first I am solving this problem. Limits from 0 to pi by 2 and 0 to a cos theta. Now r integration is r square by 2. Limits from 0 to here we have to integrate with respect to what? Z. So will you do r integration? R is a constant while integrating with respect to z. Na? So don't do r integration here. R you keep as a constant only. Now z is there here, z term? No, but you can say r into 1. So 1 is a z term. So 1 integration with respect to z is here, z only. Limits from 0 to square root of a square minus r square. Is it clear? Why we are not integrated with respect to r directly? Because first you have in terms of z, that is why we are doing integration with respect to z. One integration with respect to z is z only. So limits from 0 to square root of a square minus r square into what is the remaining terms you have? Dr d theta. Okay. Now integral 0 to pi by 2, integral 0 to a cos theta, r into upper limit and lower limit if you are substituted, then you will have square root of, this is a square root of a square minus r square into dr d theta. Okay, this is upper limit is root of a square minus r square, lower limit is 0, so I am not written. Of course if you written also same thing you will get here. Now you see I will simplify again this one. 0 to pi by 2, 0 to a into cos theta. This is r into this square root I am writing. A square minus r square minus 0 is same thing only, na? Whole to the power of 1 by 2 dr d theta. Now it is a product of two functions. Okay. Now UV rule you can apply means here you verify that integral f dash of x into f of x whole to the power of n dx form or not. If it is in this form, then you can write f of x power n plus 1 by power plus 1 by power plus 1. Now a square minus r square is there. A bracket is a square minus r square. What is the bracket derivative with respect to r? 0. Later r square derivative is minus 2r. Is there minus 2r here? No. So multiply with minus 2 and divide with minus 2. That's it. Now you observe this bracket derivative is beside. So what you can say? Bracket power plus 1 by power plus 1. So you will have minus 1 by 2 times of integral 0 to pi by 2. Bracket is here a square minus r square whole to the power of 1 by whole to the power of plus 1 by plus 1. So 1 by 2 plus 1 is nothing but 3 by 2 by again 3 by 2. Now limits from 0 to a into cos theta d theta. Now this 3 by 2, 1 by 3 by 2, so you can write like a 2 by 3. 2 by 3 integral from 0 to pi by 2 a square minus upper limit if you are substituted, then r square is nothing but a cos theta whole square, that is a square cos square theta minus lower this is power 3 by 2. Lower limit if you are substituted, then you will have a square minus 0 is a square whole to the power of 3 by 2 into d theta. Now this 2 getting cancelled, then minus 1 by 3 times of integral 0 to pi by 2. This a square and a square you will take common. From this bracket you can take a square is a common. If a square is came outside, then you will have a square power 3 by 2 will become a cube into 1 minus cos square theta. You can write as a 1 minus cos square theta. You have 1 minus cos square theta whole to the power of 3 by 2. Now that is okay. 1 minus cos square theta whole to the power of 3 by 2 minus, so this is square and root getting cancelled, by 2 whole power 1 by 2 getting cancelled, then you will have a cube into d theta. From this also you can take a cube is a common, and 1 minus cos square theta you can write as a sin square theta or not. So minus 1 by 3, a cube is common, I am writing this a cube is outside, then I will have a cube integral from 0 to pi by 2. In this case 1 minus sin cos square is nothing but sin square, so sin square theta whole to the power of 3 by 2 minus 1 into d theta. In this case square and whole power 1 by 2 getting cancelled, then you will have sin cube theta minus 1. Okay na? Now you can separate this one, then you see if I multiplied minus inside, then I will have a cube by 3 integral 1 pi by 2 1 d theta minus a cube by 3 integral 0 to pi by 2 sin cube theta d theta. So one integration with respect to theta is theta limits from 0 to pi by 2. This is 0 to pi by 2. This is a cube by 3 here I have minus a cube by 3. Here Wallis theorem I can apply. So here you have a 3 na. So how you can write this is 2 by 3 into, here can from 2 means only 2 by 3 you will have here. From the Wallis theorem you will have 2 by 3. That's it. Okay. Now what I can do, this one a cube by 3 is a common, a cube by 3 if I taken common, then upper limit pi by 2 minus 1 minus 2 by 3. Okay, then sorry, this is 0, pi by 2 minus 0, so you will have a cube by 3 pi by 2 minus 2 by 3 is the answer. Okay, thank you for watching this video.